In our lesson today, we're going to be solving systems of equations graphically. Before we get into examples that are graphing systems of equations, we're just going to review how to graph a basic equation on our graph right here. So the first thing we're going to do is rewrite our equation in slope-intercept form, which looks like y equals mx plus b. We have to identify the slope, which is m, and the y-intercept, which is b, and then we'll be able to graph the equation on the coordinate plane we see right here. Okay, so our equation says 2y minus 3x equals 10. In order to make it look like it's in y-intercept form, we have to isolate the variable y. So the first thing that we're going to do in this example is add 3x on each side. Once we add 3x to each side, the equation becomes 2y equals 3x plus 10. All right, the next thing that we have to do to isolate y is divide each side by 2. So on the left, I'm going to divide by 2, and on the right, when I divide by 2, I have to divide everything by 2. So that's going to make our equation say y equals 3 halves x plus 10 divided by 2 is 5. And so now our equation is written in slope-intercept form, and I can pick out the slope and the y-intercept. The slope is going to be 3 halves, and the value of b is going to be 5, which means that the y-intercept is going to be at the point 0, comma 5. So we can start by graphing the point 0, comma 5 first. Once we know the y-intercept, then we can use the rule of the slope in order to get the other points on our line. Remember that the slope is the rise over the run, so it's a positive 3 over a positive 2. So I'm going to go up 3 and then to the right 2 to get to the next point. So up 3, 1, 2, 3, to the right 2, there's the next point on my graph. If I try to do that again, 1, 2, I'm off the graph over here. I'm not going to be able to plot my next point, but I can go back to the y-intercept and go in the opposite direction. Instead of going up 3, right 2, I'm going to go down 3, left 2. Down 3, left 2, down 3, left 2, down 3, left 2, down 3, left 2. And then, once I've got my points plotted, I'm going to use my ruler, and I'm going to connect all of my points in a nice straight line. And don't forget to put arrows on the ends of your line, and we will label the line with its original equation, which in this case it said 2y minus 3x is equal to 10. All right, so always get your equation in slope-intercept form first so that you can get your slope and y-intercept, and then use the rule of the slope after you plot the y-intercept to get the other points on your line. The next equation that we're going to graph is x plus 2y equals 6. And again, we have to get this in slope-intercept form first, so we have to isolate that variable y. So we're going to start by subtracting x on each side, which is going to make the equation 2y equals negative x plus 6. And that's the same as negative 1x plus 6, if you want to put that negative 1 there. Next, we have to divide each side by 2, which again means on the right we're dividing everything by 2. So y is going to equal negative 1 half x plus 3. There's the equation in slope-intercept form. The slope is going to be negative 1 half, and b's value is 3, which means our first point is at 0, comma 3. That is your y-intercept. Now we'll use the rule of the slope. It's negative 1 half, so we're going to go down 1 and to the right 2 to get from point to point. So down 1, right 2, down 1, right 2, right there, down 1, right 2, down 1, right 2, and I'll do it one more time. There we go. So we have a bunch of points that we have on our line. Now we're going to use our ruler and connect them all. And we get this nice line right here. So again, we'll put the arrows on each end. And again, the original equation was x plus 2y equals 6. Our third equation is 3y plus 12 equals 5x. Let's get this in slope-intercept form by isolating the y term. So let's subtract 12 from each side to begin. 3y equals 5x minus 12. And now we'll divide each side by 3. So 3y divided by 3 is y. 5x divided by 3, we're just going to call that 5/3 x. And negative 12 divided by 3 is negative 4. Y equals 5/3 x minus 4. The slope is 5/3, and b's value is negative 4. So our first point, the y-intercept, is at 0, negative 4. And then the rule of the slope, we're going to rise 5 and go to the right 3. 1, 2, 3, 4, 5 up, 1, 2, 3 to the right. 1, 2, 3, 4, 5 up, 1, 2, 3 to the right. And we can go back to the y-intercept and do it in reverse. Go down 5, 2, 3, 4, 5, and to the left 3. 1, 2, 3. All right, and now use your ruler, and we can connect those points and make a nice straight line and arrows. And the label, this was the line 3y plus 12 equals 5x. So now that we are confident graphing linear equations, let's talk about what a system of equations is. A system of linear equations is just two or more linear equations. All right, so when we're solving these equations graphically, that means we're going to be graphing two or more lines on the same graph. All right, the solution to a system of equations is where the lines intersect. All right, the solution is where the lines intersect, and we will always write the solution as an ordered pair. An ordered pair. Now, an ordered pair is just x comma y written like that. Okay, so wherever the point is that the two lines intersect, we're going to give the coordinates as an ordered pair. And the point of intersection, I think I hit my camera there. There we go. The point of intersection, the point of intersection is the same as the solution to the system. All right, so again, to have a solution, the two lines are going to have to intersect. If there is no solution, well, this means that the lines have the same slope. And if the lines have the same slope, this means that they are parallel to each other. Parallel lines are never going to intersect, so there will be no solution to a system if the lines are parallel. Infinite solutions means that the lines overlap each other, meaning that they have the same slope and the same y-intercept, and all points are common. All right, so if we look underneath this box, we see three different graphs here that's showing the three different possibilities. In this first example, the lines have different slopes, so there's a point of intersection. The lines intersect, so there is one solution. In this middle graph, they have the same slope but different y-intercepts, which means that the lines are parallel. And if the lines are parallel, there is no point of intersection, so there is no solution. With our third example, the lines have the same slope and the same y-intercept, which means that the lines are overlapping. And if they are overlapping, there are infinitely many solutions. Infinitely many solutions when the lines overlap. Now that we understand what a system of equations is, we're going to look at our first system and solve it graphically. So I have my two different equations. I'm going to graph them both right here. And then I'm going to look for a point of intersection, which is going to represent the solution to the system. The first thing that you always want to look for is that your equations are written in slope-intercept form, y equals mx plus b. And fortunately, looking at both of these equations, we can see that they are both already written in slope-intercept form, which means I can start to graph the equations on this graph right here. So if we start with this first equation, y equals negative 1/2 x minus 1. All right, the value of b is negative 1, which means that the y-intercept is going to be at 0, negative 1, that point right there. Then I'm going to use the rule of the slope. It's negative 1/2. So I'm going to go down 1 and to the right 2 to get from point to point. So follow the rule, down 1, right 2, down 1, right 2, down 1, right 2, down 1, right 2, and I'll do it one more time. There we go. So all of those points are on the first line, and now we're going to use our ruler to connect all of those points together. And we should get a nice straight line, which looks something like this. All right, and we will go ahead and put our arrows on the lines. But I'm not going to label just yet because I still have one more line to graph and my label might get in the way. So I'm going to hold off on the label for now. My second graph, y equals x minus 4. The b value is negative 4, which means the y-intercept is at 0, negative 4. And then for the slope, x is the same as 1x, so the slope here is 1. All right, so 1 is the same as 1 over 1, so I'm going to rise by 1 and go to the right one. Up 1, right 1. Up 1, right 1. Up 1, right 1. Up 1, right 1. There's a bunch of points. Use the ruler to connect them. And we will get another nice straight line, which looks something like that. And now I'll go ahead and put my labels on it. This was the second line that I just drew, which was y equals x minus 4. And this was my first line, which was y equals negative 1/2 x minus 1. And looking at the original equations here, I could tell that the lines had different slopes. And when they have different slopes, that means that they are going to intersect, which we can clearly see at this point right here. So the solution to the system is the point of intersection. And this point is at 2 comma negative 2. So the solution to this system is 2 comma negative 2. The next system that we're going to solve graphically says y equals 3x plus 2 and y equals 3x minus 2. Both of these equations have already been written in slope-intercept form, so I can start to graph these lines right here, and then again, I'm going to look for the solution, which is the point of intersection. Before I do that, though, doing a little investigation right here, I see that both of these lines have the same slope of 3. But they have different y-intercepts. If the lines have the same slope but different y-intercepts, that means that when I graph it, the lines should be parallel to each other, and parallel lines never intersect. So down here for the solution, I'm going to take a guess, and I'm going to say that there is no solution to this system because, again, the lines should be parallel and never intersect. Let's graph this first line right here, y equals 3x plus 2. The value of b is positive 2, so the y-intercept is at 0, 2. And now the slope is 3, which is the same as 3 over 1. So I'm going to go up 3, right 1. Up 3, right 1. Up 3, right 1. And then I can go back to the y-intercept and do it in reverse. Down 3, left 1. Down 3, left 1. And I'll do it one more time. Down 3, left 1. And there's a bunch of points for my first line. Use my ruler. And I connect all of my points nicely there. There is my first line. And again, I'm going to hold off on the label for now. My second line, the value of b is negative 2, so the y-intercept is at 0, negative 2. Same rule for the slope. I'm going to go up 3, right 1. 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 And then again, I can use my ruler to connect those. And just as I thought would happen, My two lines are parallel to each other and they do not intersect. So there is no solution to this system. All right, but I am going to go back and label. This was y equals 3x plus 2, and this was y equals 3x minus 2. So again, just by investigating your equations at the beginning, you should have an indication of whether there should be one solution, no solution, or infinite solutions. Our next system of equations says that y equals negative 4 thirds x minus 4 and 2x minus 3y equals negative 6. All right, and this problem has a little bit of a twist on it because this second equation is not written in slope-intercept form. The first one has already been written in slope-intercept form, but we're going to have to do a little work here with the second equation. We've got to isolate this variable y. So the first thing that I'm going to do on each side, I'm going to subtract that 2x on each side. So now I'm going to have negative 3y equals negative 2x minus 6. And now to isolate y, I'm going to divide everything by negative 3. Divide by negative 3 on each side. Negative 3y divided by negative 3 is y. Negative 2x divided by negative 3. Negative divided by negative is positive, so I'm going to make that 2/3 x. And negative 6 divided by negative 3 is positive 2. So I'm going to have the line y equals 2/3 x plus 2 to graph for my second equation. And just looking at the equations, I see that they have different slopes, which means that my lines should intersect, so there should be a solution here. So let's start with the first line, y equals negative 4 thirds x minus 4. B is negative 4, which means the y-intercept is at 0, negative 4. And the slope is negative 4 thirds. So I'm going to go down 4 and to the right 3 to get to my next point. Down 4 to the right 3. And again, if I try to do that again, I'm going to be off the graph. So go back to the y-intercept and do it in the opposite direction. Go up 4 and to the left 3. And I can probably do that one more time. Go up 4 and to the left 3. And now I can use my ruler to connect those points. And this is the first line in our system. Put the arrows on it. Our second line, written in slope-intercept form, y equals 2/3 x plus 2. We're going to start at 0, comma 2, since the value of b was 2. And then the rule of the slope, go up 2 to the right 3. Up 2, right 3. Up 2, right 3. Up 2, right 3. There we go. Use the ruler. Make sure I don't hit my camera again. And when we connect these points, we get this nice line here. And again, put the arrows on the ends. And now I will label. This was my second line, which was originally written as 2x minus 3y equals negative 6. And my first line here was y equals negative 4 thirds x minus 4. And just like I thought, there is a point of intersection. It's at this point right here, which is going to be at negative 3, comma 0 for the solution to that system. The next system says y equals negative 2x minus 7 and 3x minus y equals 2. And just like with our previous example, our top equation is in slope-intercept form while the bottom one is not. So we've got to isolate that y term right there. So let's subtract 3x on each side to start. Negative y equals negative 3x plus 2. And that's really the same as negative 1y. So to isolate y, I'm going to divide everything by negative 1. Divide each side by negative 1. And that's going to give us y equals 3x minus 2. All right, negative divided by negative is positive. Positive divided by a negative is a negative. And so there is our second equation. And again, looking at this equation here, I can see that they have different slopes. All right, my equations have different slopes. So there should be a point of intersection, which means we will have a solution. Our first equation, y equals negative 2x minus 7, we're going to start at 0 comma negative 7 since that's our b value. And then the rule of the slope, negative 2 over 1, down 2 to the right 1, down 2 to the right 1. And again, I'll go back to the y-intercept and do that in reverse. I'm going to go up 2, left 1, up 2, left 1, up 2, left 1. And we have a bunch of points that we can now connect. And go ahead and connect those with the ruler. And there's our first line. Our second line, when written in slope-intercept form, y equals 3x minus 2, we're going to start at 0, negative 2. And then 3 is the same as 3 over 1, so we're going to go up 3, right 1. Up 3, right 1. Up 3, right 1. Up 3, right 1. And now I can connect all of those points. And we get that line right there. And again, let's give the labels. This was the second line that we drew, which was originally 3x minus y equals 2. And this was our first line, y equals negative 2x minus 7. And just like I thought, there is a point of intersection found right here at the point negative 1, negative 5. So that is the solution to this system of equations. In our next system, we have 4x equals 2y minus 10, and we have 2y equals 4 plus 4x. Notice in this example that neither equation is written in slope-intercept form, so I'm going to have to rewrite them both before I can graph them over here. All right, I'm actually going to start with the second equation because all I need to do to isolate the y value here is divide both sides by that 2. So I'm going to divide by 2 on the left, and I'm going to divide everything on the right by 2 as well. So that's going to make the second equation say that y equals 2 plus 2x, which is the same as 2x plus 2. Y equals 2x plus 2. So that's the second equation. And the first equation, I'm just going to rewrite down here and then isolate the variable y. Okay, so the first thing I'm going to do here, I'm going to add 10 to each side. So 4x plus 10 equals 2y. And then if I divide both sides by 2, I'm going to get 2x plus 5 equals y, which again is the same as just writing it as y equals 2x plus 5. So there's my second equation. And now these are the two equations that we are going to graph. If you notice both of their slope-intercept forms, they have the same slope of 2, but they have different y-intercepts. Well, same slope and different y-intercepts means that I should get some parallel lines here, which once again is going to mean that there is no solution to this system. All right, so let's start with the first line. I'm going to start at 0, comma 2 for the b value. And then the slope is 2, which is 2 over 1. Go up 2, right 1, up 2, right 1, up 2, right 1, up 2, right 1. And then we can graph that easily. Connect those points. And there is our first line. Our second line is going to start at 0, comma 5, since that's our b value. And then again, it's the same rule. Go up 2, right 1, up 2, right 1. And I'll do one more. I'll go back to the y-intercept and go down to left 1 to just get another point. And then again, I'm going to go ahead and connect those. And you can see pretty clearly we have two parallel lines that will never intersect, therefore no solution. All right, so this was actually our second line, which was written as 4x, or excuse me, this was the second line, which was written as 2y equals 4 plus 4x. And then this was the first line. All right. This was the second line, excuse me, I'm confusing myself, which was 2 y, I think I've got my labels mixed up here. Pardon me one more time. This one had the y-intercept at 5. So this is the first line, which was 4x equals 2y minus 10, my mistake. And then this was the second line, which was 2y equals 4 plus 4x. All right, pardon my blooper. The last system that we're going to solve graphically says that y equals 2x plus 3 and 2y minus 6 equals 4x. And you can see by looking at the system that the top equation is written in slope-intercept form, but the bottom one is not. So the first thing we're going to do is write that bottom equation in slope-intercept form. So we've got to isolate y. We'll start by adding 6 to each side. So 2y is equal to 4x plus 6. And now we'll divide each side by 2, which means that y equals 4x divided by 2 is 2x plus 6 divided by 2 is 3. So we get y equals 2x plus 3, and we had y equals 2x plus 3. Notice these lines are exactly the same slope, same y-intercept, which means the lines are going to overlap. So for our solution, there is going to be infinitely many solutions in this example, since all of the points are going to be common. So we can start by writing at the y-intercept 0, 3, and then using the rule of the slope, 2 over 1, up 2, right 1, up 2, right 1, up 2, right 1. And then we'll go ahead and connect those. And again, our second line is going to be exactly the same as this one, so I really just have to graph this once. There is the line that represents both of the equations, so I could label it as y equals 2x plus 3, and I can also label it as 2y minus 6 equals 4x. But again, these lines are equivalent, so there are infinitely many solutions to this system of equations.